minus sine alpha into 1 plus sine alpha into this is sine 90 degree, which is 1, and this is sine minus alpha, which is minus sine alpha. So we can cancel out 1 minus sine alpha. So finally we are left with u square into g into 1 plus sine alpha. So this is the value of maximum range of a projectile which is projected along a inclined plane, inclined at an angle alpha. So this is our R max. Now let's talk about a special case where the projectile is hitting the inclined plane in the perpendicular direction. So here, as you can see, if the impact of projectile with the inclined plane is perpendicular, that is in this direction, then the component of its velocity along the inclined plane, that is in x direction, will be 0. Now the velocity along x direction can be given as ux plus at, where a is the acceleration along x direction and it is equal to minus g sin alpha. So the velocity along x direction at any given time t is given as ux, which is u cos beta, plus at, where a is minus g sin alpha. So this velocity will become 0 at time t is equal to u cos beta by g sin alpha, and this is also our time of flight, because at the end of the flight the projectile is hitting the inclined plane in a direction perpendicular to it. So we can equate this time to the time of flight, which is 2u sin beta by g cos alpha. So from here we can cancel out u and g, so we get sin alpha by cos alpha into sin beta by cos beta is equal to 1 by 2, or tan alpha into tan beta is equal to 1 by 2. So this is the condition for which the projectile will hit the inclined plane. Now we will start the chapter kinematics of circular motion. So first, see what is a circular motion. Circular motion is rotation along a circle, that is a circular path or a circular orbit. Circular motion can be either uniform or non-uniform. With uniform circular motion we mean that the angular rate of rotation is constant, and in the non-uniform circular motion the angular rate of rotation is not constant and it is varying with time. Now let's see some definition. First we'll define angular displacement. Angular displacement is the angle subtended by the arc traveled by the object at the center. So let's see this with the help of an animation. So here we can see that this delta S is the arc of a circle, and this is the center of the circle. Let's say this O. So an object travels from point A to point B, making an arc, the length of which is delta S. R is the radius of circle. So as we can see here, this arc makes an angle delta